You are watching the 8.1 lesson video on Introduction to Systems of Functions. Now, before we begin talking about the solutions to systems of functions, I wanted to revisit what a solution is to an actual function. And a solution to a function, it says it right up top, is any point that lies on the graph of the function. And this is no surprise because in order to create a picture of a function, we want to look at all of the points that make up the function. So all of those points make the function true, therefore they're solutions. Now if we read on, exercise number 1 wants us to do a ton of things for each of the different parts A, B, and C. So we first need to determine the type of the function, so linear, quadratic, absolute value, square root, whatever it might be. Then from the graph, we will get the table of values, and we will write the equation of its parent function, and then use the parent function equation to help us write the equation of f of x, the function that they have given us. And then we will determine 3 solutions for each function. So if we look at A looks to me like it's a straight line, so you guessed it, we are looking at a linear function. Now let's get the table of values. So what they want us to do is pull all of the points, and I shouldn't say all of the points, I'm just going to pick the points that have nice intersections because then I don't have to play a guessing game of what the decimal actually is. So I see the point -6, 4, and I think I might be able to get both these on my screen. I can. So we have -6, 4. I always go from left to right, read a graph like I read a book. -3, 3, 0, 2, 3, 1, and then lastly, if we just see the pattern in the x and the y's, we can see that our next point would indeed be the 0, 6, 0, so the root. Okay, so the equation of this parent function, well, it's a linear equation, so it's as simple as can be. In this case, we would usually use y equals mx plus b, but the parent function is just y is equal to x. And if we graph this on the graph, let me use a different color. Y equals x is just this line here. Now, I would say linear equations, we don't talk too much about shifting linear equations because, well, what do we usually do? We usually just use y equals mx plus b. We use the slope and the y-intercept. So let's go ahead and do that with our function of f of x. So we will follow the formula y is equal to the slope times whatever our x value is, and adding on our starting value. So our starting value is our y-intercept, which is 2, so we're going to add 2. And of course, y and x always stay the same. And now I need to find my slope. So the slope of this line is rise over run. Let's not forget that, rise over run. Change in y divided by change in the x. So again, we read a graph like we read a book. So down 1, to the right 3. So my slope is -1/3. And 3 solutions. Well, what are solutions? Solutions are any point that lies on the line. So I can actually pull all of my solutions from this table of value. I mean, I could get creative and try to get points that are not in the table of values, but why would I do that? Why would I make it harder? So let's just list off the first 3 here. -6, 4, -3, 3, and the y-intercept of 0, 2. Those are 3 solutions, 3 points. All right, moving on to B. What type of function is this? It makes a V. It's upside down, but it's still a V. So if you guessed absolute value or you knew absolute value, you are correct. Okay, let's bring up the table of values. Now, there are a ton of points on this graph. So what are the most, or what I guess is the most important point? Let's start from there, put it in the middle, just like what we would do with a parabola, which is dun dun dun, the vertex. This is a point 0.25. So I'm going to put that right in the middle of the table and generate 2 points to the right and 2 points to the left. Now, of course, we can put way more points in there, but remember, putting the vertex in there, I think, is one of the most important points. So we also have the point 3, 4, and 4, 3. We also have the point 1, 4, which is this guy right here, and the y-intercept of 0, 3. We can also see the x-intercept, which happens to be at -3, 0. Okay, so the equation of its parent function, that's y equals not just x, because it's the absolute value function, it's y is equal to the absolute value of x. So I really like to see the parent on the graph in order to find the equation. And this is all stuff that we've done before, so hopefully this is a lot of fun, super fun review. And my line isn't that great on the left side, but you get the picture. The equation of f of x. Well, in order to do this, I really like to see how it has changed. So for me, I see actually, it looks like 3 changes. Now some of you might say 2, or where are you getting that third one from? So let's talk about it. Well, it looks like we shifted the vertex up 5. We went to the right 2. And it also flipped. I could also say reflected over the x-axis. So if we want to come up with the equation, we start with our parent. Y is equal to the absolute value of x. I'm going to leave some spaces in there because we have some changes that have happened. We know that, first of all, it went up 5. So if it moved up 5, there'll be a +5 on the outside. Right 2 would be a -2 inside the absolute value, and a flip means that there is a negative out in front. And remember, you can always use your technology to verify. Okay, 3 solutions, that's any 3 points. So let's get them from our table of values that we see right up above. And you know what, I'm going to pick 1, 4. I told you 2, 5 is my favorite because it's a vertex, so let's list that. And 3, 4. And I guess, you know, you didn't have to write them in order. I'm just writing them in order because it's easier for me. All right, moving on to C. What type of function is this? It's a U. Well, it's a parabola. I shouldn't call it a U because that's not correct math terminology. It is a quadratic function. And we talked a lot about quadratic functions this year. We probably spent over a month talking about them because they're so amazing. All right, now let's pull the table of values from this lovely function of f of x. Again, like the absolute value function, the vertex for me is pretty important. Then I notice all of these awesome points that have nice intersections, nice integer intersections. So I'm going to start with the vertex, which happens at +2, -3, and then I'm just going to put as many points in as I can. So to the right, it looks like 3, -2, and then also for 1, we can tell right now that the roots are actually, or are probably irrational numbers. If not, we don't have a really easy factoring question because we can see that the roots are not falling on the integers on the x-axis. Then to the right of the function, we have 1, -2, and then also 0, 1. The y-intercept is there, and there's my vertex. So the equation of the parent function, you got it. We know something is a quadratic if it has x squared in it. All right, so let's now graph that parent function. Hopefully you know what this is by memory now. I should make these points a little bit easier to see. But this is what we're transforming. So we have to figure out how did my orange, my parent, transform to become my f of x function. It went down 3, and it went to the right 2. So again, we start with the parent. You know, I wrote y for all these. I gotta go back and change that. That should not be y. We want the equation of f of x. Shame on me for not catching that sooner. F of x is equal to, well, we usually start with x squared. However, we need to do a shift of left and right. So in order to do that, we had a shift of right 2. So that would be x minus 2 inside the parentheses, and down 3 would be minus 3. And let me just go back and fix these. These are all f of x's. F of x, f of x, f of x. And then 3 solutions. Once again, I'm not going to write them in any particular order this time. I'll say 2, negative 3. I like the vertex. I also like my y-intercept of 0, 1. Remember, we're just pulling these points from the table. And let's use 4, 1. Okay, so now that we've talked about solutions to functions, let's talk about solutions to systems of functions. More than one function graphed on the same grid. So exercise 2 wants us to first identify the 2 different types of functions. We're just going to write out the names. So is it linear, quadratic, exponential, blah, 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 blah. And then we are going to determine the solution to the system. Sometimes there's more than one, sometimes there might not be any. But we know a solution, and let's actually just highlight that, a solution is going to be wherever the 2 functions intersect, okay? And that is going to be the point of intersection, and we will list this off as a coordinate. All right, so A, well, we're looking at 2 lines, so the graph of f of x and g of x, they're both linear functions. The solution, well, where do they cross? I'm going to show it right up here. I know it doesn't tell me to do that, but it helps me to see it a lot better. The solution is at the point negative 2, 2. That's it. Okay, moving on to B. F of x is this function right here. I can't really arrow over it, but, well, maybe I can. Can you see the arrow? No, you can't. Okay, so f of x is the function here, which, of course, you know that this is yet another linear. And the other function is, you are right, absolute value. Now, if we look at the solutions, we want to see where the 2 functions cross. And this actually happens in 2 spots. So we have, you guessed it, 2 solutions. The point 1, so sorry, negative 1, negative 2, and the point 3, 2. All right, moving on. C, what is f of x? What type of function is f of x? It's a quadratic. And g of x is a linear function. Okay, so where are they crossing? Well, it doesn't look like they're crossing on here. If we extend the line, do you think that they're ever going to touch? So that line just keeps going, that keeps going. If we continue our parabola, that just keeps getting higher and higher. Will these ever intersect? And the answer is no. So if we talk about the solutions that they have, there are no solutions. They will never intersect. Sometimes you see it written like this. That means it's the empty set. So we can also write that out in words, just in case you ever see that vocabulary appear. So empty set means no solutions. The two functions will never ever cross. Now, this scenario I always want you to be really careful of, because sometimes it does have a solution, but you just have to change your window in order to see it. So no matter what we do, we will see the two functions never intersecting. So moving on to both D and E, I'd like for you to pause the video now and try these two on your own, and then come back to me to check your answers. Okay, so here are the answers to both D and E. Take a minute if you need to, pause the video, and fix any mistakes if you had any. So our last exercise, number 3, we need to use our calculator to determine the solution or solutions to each system of functions below. So now is the time to take out your graphing calculator. Let's add a graph, and we're going to type in both of these functions. So x squared plus 5x plus 6. Great, I see a parabola, that's what I wanted to see. And then also 2x plus 10. Let's hit enter. Now, the first thing that I notice about this function is that, or system of functions, I should say, is that my window is definitely not big enough. I can see that my line is continuing and probably is going to cross up here somewhere. So what we want to do is we need to change our scale. This number is a lot easier for me to change, so I'm just going to double click that and hit tab a couple times to jump up to the 6.67. And let's try, I'll try 20. Ah, perfect. So now I see the 2 points of intersection. So what we can do in our calculator is hit menu, and we would like to analyze the graph and find the intersection. So it looks like there's 2 intersections. Is this going to let me do this? I don't know if this will. Oh, it is. It's just being a little weird. Okay, so click once, click again, and we can see one of the points of intersection is at -4, +2. And we have to do the same process again. Analyze graph. We want to find the points of intersection up here. Click and drag. And if you need to, you can move the point off to the side by pressing and holding the click button or hitting Control click to see that the other point of intersection is at 112. Okay, pause the video, go ahead and graph B and come up with the points of intersection on your own. So for part B, you should have found the intersection point at 2, 5. Now there's actually another way that you can find intersection points on your calculator. It's a little different than what we were doing before with finding the points using the Analyze Graph feature. Instead, you can actually find all of the intersection points at one time by using the geometry feature. So I just wanted to show you both ways. It really doesn't matter to me how you find them. The Analyze Graph feature is definitely more common because we use that feature a lot more with, finding the roots and things of that nature. So what we could do instead is click 8 Geometry, and we want to find points. We want to find points of intersection, so we're going to select 1, and then we're going to select intersection points. And nothing appears because what we have to do on the calculator is select, using our mouse, the first function, and then the second function, and then you will see the 0.25 appear. So that's just yet another way that we can find points of intersection of systems of functions. All right, pause the video one last time and complete part C. So the answer to part C would be no solution. You could have also said the empty set. And it's not no solution because when you initially graphed it, you didn't see a graph appear. So what I actually had to do was change the window of my function to see that indeed these functions will never intersect. So no matter where I click and drag this to, the functions will never ever meet or cross, therefore no solution.